Hello, everyone. I hope you're doing well on this Thursday afternoon. We are going to give everyone a couple of minutes, as usual, to get signed on and get ready to go. So we will be beginning the lecture at 2:03 p.m. If you do have any questions, as usual, please go ahead and type those now, and I'll start kind of addressing those if we do have any. But otherwise, I'll talk to you guys at 2:03. Thank you. All right, it looks like we are about ready to get started, and there are no questions in the box right now, so I'm going to go ahead and just kind of jump right into it. Just to kind of remind you, we are currently in week 5, and we did chapter 11 on Tuesday. We're going to cover chapter 12 on growth theory today. Just kind of a side note, if you have some extra time or if it's something that you're interested, it's not a mandatory assignment or anything like that. But I was able to listen to a talk with Greg Mankiw. If you're not familiar with him, he is a professor at Harvard. He served as the chairman of the president's kind of economic council of advisors for some time. And he just kind of gave a brief update of like his thoughts on how the economy is doing and kind of what the outlook is coming in the future months and things like that. And it was just kind of like a general update for anyone that is sort of curious about, what the economy might do or wants to know some more kind of like up-to-date economic information. So I will be sending that link out via our announcements here in the next couple days. So if you have some time, I definitely encourage you to watch that. Greg Mankiw is a really renowned and brilliant economist, but he's also very interesting to listen to. So I know that sometimes when you're trying to learn about economics or you're trying to kind of figure out what's going on, that the videos can be a little dry. So that is, economists are not entertainers. We're all well aware of that. So I will send out that link. One of the things that he kind of touches on is how if you look at the autobiographies or biographies of any great economist, that one thing that they typically will have in common is that, a bad financial time or recession or some kind of economic event in their lifetime is what inspired them to study economics and become economists. And it's pretty well known that, recessions and interesting times like what we're currently going through tend to breed brilliant economists. So if any of you are becoming more interested in this subject just because of the current state of things, this would be a great video for you to watch. So I'll definitely send that out. It's about 45 minutes long or so. And again, it's not for a grade or anything like that, but it's just some really good information about sort of the current state of the economy and what he foresees happening in the next coming months. So just a little side note there. But let's go ahead and get started on chapter 12. So much like chapter 11, this chapter really just kind of expands on those ideas. So growth theory goes into a lot more detail about sort of what causes, economic growth to happen, what are some things that hinder economic growth, and really just sort of gets a little bit deeper into a lot of the things that we talked about on Tuesday. So if you weren't completely sold with Tuesday's lecture, this should really kind of drive that home for you and provide some additional clarification. Just kind of a side note before we start getting into this chapter again, an interesting thing to think about is that the USA often provides a lot of aid to foreign countries that are in need. A good example to keep in mind is Haiti. After they had earthquakes and some significant weather events, natural disasters, there were, millions and millions of dollars in aid that went to Haiti. And a lot of economists kind of started to notice, and a lot of people, not just economists, that Haiti really didn't rebound from that, and the aid didn't seem to actually help. And there were a couple of different reasons why that aid didn't help, but I want you guys to kind of think about maybe why foreign aid isn't always like as helpful as we would like it to be. It's called the paradox of foreign aid, and it's something that we'll talk about a lot this chapter. But maybe just think about it and post in the comments if you know, like maybe why foreign aid doesn't always fix the things that we think it's going to fix. So on Tuesday, just in case you've slept since then, we talked about economic growth, and we talked about how that growth is very kind of central to the modern macroeconomics, and it really helps us have an understanding about how we might be able to improve living standards in other countries. We also talked about how only recently, and by recently they mean in the last 200 years, standards of living have really started to improve. And we talked about how changes in the per capita real GDP affect welfare. Remember, changes in that per capita real GDP, these are economic growth. We care about the average person and how their kind of income is going, and that's why we calculate it that way. And then we talked about how the main factors that contribute to economic growth are resources, technology, and institutions. So I see Eric said, perhaps the government did not use the money properly. And that's really one of the main things. So when we give foreign aid and we're sending money to these countries, we're really hoping that that money will be distributed properly and to the people that need it the most. And in a lot of cases, in countries that aren't as developed, there is corruption in the government and things like that. And these millions and millions of dollars of aid are not properly accounted for. And that's a really good observation that the government allocation of that money was not, assigned properly, and that's something very common. So great comment, Eric, thank you. Now, the big questions for this chapter are how do macroeconomic theories evolve? So how do we come up with these things? When do we change them? How do we know that we need to change them? We'll ask, what is the Solow growth model? So Robert Solow is the economist behind the Solow growth model. We'll talk about what that is here in a minute. We'll ask ourselves, how does technology affect growth, and why are institutions the key to economic growth? So Eric's kind of already on the right track here, talking about the government allocation of money, and the government is one of those institutions that is very key to economic growth, and we'll talk about that more towards the end of this chapter. So the Solow growth model, let me go ahead and pop all of this up for you. This model takes our sources for economic growth, resources, technology, and institution, and it kind of like puts all those together. So growth theory started about 60 years ago with Robert Solow. This model still is the basis of the growth theory, but this theory has really changed significantly in the last 20 years. So we want to know, why do we care about this? Well, economic growth theory and policy, they both have really significant impacts on human life. We really need to get the best answers to growth questions, and this really matters in determining what are these kind of secret ingredients to economic growth. Economists have really studied a ton of different factors that they think might contribute to economic growth, but this is kind of the best model that we've had so far. I see Teresa saying that she can't hear anything. Can anyone else hear me right now? I'm going to just pause for a second and see if you guys can hear me and let this catch up. Okay, Mario can hear me. Teresa, if you still can't hear anything, well, I guess it won't really help me to tell you. Let me just go ahead and type her a comment really fast. All right, so hopefully that will get Teresa fixed up. But back to this slide, there's really a fundamental consensus among a lot of economists with regard to the factors that are necessary for growth. So there's a lot of different schools of thought of kind of the mechanics of things, but the real like specifics and kind of the bottom line of things, we all agree on this. Okay, I think that Teresa's okay. But the factors that have kind of the most important relationship to growth are going to be our resources, technology, and institutions. And this consensus is really a result of the growth theory that started from Robert Solow and the Solow growth model. So I'm just going to pause for just a second here to refresh my screen and see if we can't get Teresa fixed up, but it seems like it might be on her end. So if you'll give me just 1 minute to get this fixed for her. Okay, so moving on a little bit here. There's a lot of interplay between the real world and economic theory. In a lot of academic disciplines, new ideas and theories are really going to spark a lot of intellectual debates. In economics, many of the theories are put to the test in the real world. So that's kind of an advantage that we have in this arena. So a good example of this, John Maynard Keynes, so Keynesian economics, his ideas were implemented immediately by FDR. So Solow's ideas about growth, these were also acted on immediately. In economics, we really go idea, policy, and then welfare effects. It's like a very quick transition. And the chart on this slide is going to kind of show the cycle of relationships between theory, empirical data, and policy. So you can see that we have these real-world observations. We come up with economic theories. These theories turn into policy. The policy generates more real-world observations, and it just kind of keeps going around and around. It's going to be a cycle because these theories are always being reworked because we see policies in action and we kind of see the effect that they have on the real world. Policymakers really, they often have to convince people, which are voters, that they're trying to help them, especially when things are getting difficult. So like right now, you know, with things like the stimulus plans and the CARES Act and all of these different legislations that are coming out, obviously not everyone is going to be sold that these are great ideas and the right solution. And we kind of have a lot of, you know, Monday quarterbacking that goes on in economics. So whenever you have an idea of what you think is the right idea, it's easy to kind of comment and think that you would have handled something better. But at the time, they're really just trying to work with the information they have to make the best decisions. So when the economy is in a trove business cycle, remember that's low or negative growth and high unemployment, kind of like things are now. Politicians really look to economists to get advice on how we can help the economy recover. So economists are very crucial to like the overall well-being of our, you know, economy and GDP and things like that. And they're constantly trying to work out these problems. Now, economic theory is often turned into policy very quickly. And historically, as with many things, this sometimes fails. Sometimes the theories that they come up with are incomplete or erroneous, or they're just not really the best course of action. And that's because we're trying to act so quickly to turn theory into policy and then to kind of combat bad things that are happening. Now, this is kind of both good and bad news for growth theory. The good news here is that growth theory is important enough to impact the welfare of billions of people around the world. And that's also the bad news. So growth theory is so important that we're impacting the welfare of billions of people around the world. And what that means is that if we're wrong about growth theory or we have an incomplete theory, we can push out faulty policy prescriptions, and then those policies can kind of perpetuate that poverty for millions and millions of people. So that's like a really kind of scary thought. That's why we really have to try to get these things right. Now let me go ahead and pop this slide up and we'll talk about it. This is the production function. It's the relationship between inputs and outputs. And for the macroeconomy, the output here is GDP. So essentially the Y in this equation is GDP is equal to, and the way that we read this is a function of physical capital, human capital, and natural resources. Now this doesn't really look like kind of the typical mathematic formula that you would use. This is more kind of a denotation of what the formula is and where the equation comes from. So in order to calculate our GDP or our production function, we have a function of what makes up physical capital, human capital, and natural resources. And we'll kind of break each part of this down. So this isn't like something that you would just plug into. This is just kind of a theory in itself. So the equation kind of communicates the idea that GDP in any country really depends on the resources that are available for production. All other things being equal, the more workers, so labor and human capital that you have, the more production that you're capable of. In addition to that, the more tools, so physical capital and natural resources, which is going to be land and other things, the more output that you have. So resources really matter. And that's kind of a fundamental aspect of growth theory, is that the resources that you have and the way that those resources are kind of applied is going to make a very big difference on how productive you are as a nation. Now, the focus on physical capital was kind of the primary thing that was with the Solow model. The early Solow model really just wanted to focus on the availability of capital goods. So first, based on theory, the more physical capital available would mean more production. Second, this Solow model observed that capital stock in wealthy nations is higher than that of developing nations. So wealthy nations have more of these capital goods than developing nations did. And then third, their data showed that investment is usually increasing during periods of expansion. So all of these things appear to point to capital and investment as the primary source of growth. So the key word here is appear, right? We saw these three reasons. And we said, okay, looking at these, we think that capital investment and investment are the primary things that drive growth. And that's what we thought for a long time. And that is what the Solow model kind of tells us. Now, this graph right here is figure 12.2 from your book. On the x-axis, we have our real investment growth rate in a percentage, and then our GDP growth rate. And you can see that as investment grew, GDP also grew. But remember, you guys are smarter than that. We know that correlation isn't exactly causation. They can be contributing factors, but it doesn't mean that investment is the only reason that our real GDP grows. So growth in real investment is positively correlated with growth in real GDP. Again, that kind of tells us that if you were to draw a line through these data points here, we would have an upward trend line. However, it's really kind of unclear from this chart whether this actually implies causation and in which direction. So, like I said before, remember spurious correlations, the website that we looked at. Just because things go together doesn't mean that it's necessarily the only reason. So moving on, let's just go ahead and pull this slide up. We have to recall that formula that we just looked at, that output is a function of the three pieces that we talked about already: physical capital, human capital, and natural resources. Marginal product is the change in output divided by the change in an input. So what we're looking at here, we have a marginal product for each input. The three inequalities are implicitly stating that kind of ceteris paribus assumption of just adding one input while holding the others constant. So the marginal product of each input is positive. If we add any more of any input, output will increase. So kind of what we're looking at here, if you're more mathematically inclined, the marginal product is a partial derivative of y, or output, with respect to a particular input. Now, that's not math that we'll get super into in this class. We're going to do a couple of examples that'll make this make a lot more sense. But essentially, all that these three things are saying is that if we increase any one of these things, physical capital, human capital, or natural resources, we'll have an increase in output. So it's just a really kind of fancy economic way of listing things. But all that they're saying here is a very kind of simple concept that if you increase your physical capital, or you increase your human capital, or you increase your natural resources, your output will increase. Now, a simple example here, we have table 12.1 from your book, and we're talking about Chuck Nolan's production function. So consider a situation when the entire macroeconomy is only made up of one person, and the example that they give you is Chuck Nolan, in case you don't know who that is, was played by Tom Hanks in the 2000 movie Castaway, and he finds himself stranded on this island in the South Pacific after his plane crashes. So in this case, Chuck's individual or his microeconomic decisions are also macroeconomic decisions. And the reason being, he's the only person in the economy. So we're doing a very small example here to represent kind of the bigger picture. The GDP of Chuck's island is going to include only what he produces with his resources. So he's producing fruit, and that fruit is produced through a combination of his resources, so physical capital, human capital, and natural resources. Some examples of physical capital, or one example is a bamboo ladder. Human capital in this case is Chuck's time and his knowledge. And the natural resources on the island are fruit trees and bamboo. So the GDP is going to be equal to the fruit that he harvests. And this is showing his production function and some of the resources that he has available. So all else being equal, if we don't change anything else, the more that Chuck has of any of these resources, the more fruit that he'll be able to produce. So the more GDP he'll be able to produce. Economic growth is going to occur if he produces more fruit per week. So let's say that in week 1, he was producing 1 article of fruit, and then the next week he produces 2. That's economic growth because he is the entire economy. Now we're going to continue this example on this next page. A ladder helps gather fruit, right? Will a second ladder help him? Yes, it is likely. Let me go ahead and pop this up. So Chuck Nolan would be really happy if he found a new grove of mangoes on his island and some newfound resources that could increase his GDP. Resources they also help in actual macroeconomics. So, and an example outside of this, if you discover natural gas in the US, this would have increased, these discoveries have increased pretty dramatically over the last 2 decades. And having this new energy resource really allowed the US to produce more with cheaper resources because natural gas is cheaper than crude oil. So in order to be able to kind of quantify how helpful this resource is, we have to employ that concept of marginal product that we've been talking about. The marginal product of an input is going to be the change in the output that happens with one additional unit of input. So in our Castaway example, that would be, what is the change in fruit output with one additional ladder? Or what is the change in fruit output with one additional mango tree? That kind of thing. A second ladder would be helpful. Maybe it means that instead of having to climb down off the ladder, carry his ladder over to another tree and then climb back up on the other side of the island, it saves him some time. But the marginal product of the second ladder is less than that of the first. So we'll look at that in numbers on this next graph. But as the quantity of a resource increases, the marginal product of that resource is going to decrease. So here's our little graph, and we have capital on the x-axis and output on the y-axis. Capital is going to be our number of ladders that we have for this example, and our output is going to be our bushels per week. So here's our kind of curve that shows the hypothetical relationship. And you can see these different points that we have here of the number of ladders and the bushels that we'll be able to output. So with 0 ladders, we can output 1 bushel a week. With 1 ladder, we can output 4 bushels per week. With 2 ladders, we can output 6. With 3 ladders, we output 7. And then you see that it levels off. It eventually is not going to get any better than 7. And let's think about why that might be true. why would his output not consistently just keep going up and up and up no matter how many ladders he had? So I'll give you guys a second to think about that. And you can think about this not even just with the Castaway example, but with any example. Think about if you own a McDonald's franchise. If you add one more worker, they're going to get more productive. If you add two more workers, they're going to get productive. But if all of a sudden you have 100 workers crammed into your McDonald's, are they going to be productive anymore? What do you think is going to happen? So I'll let y'all think about that and type some comments, and then we'll talk about your answers here in just a second. So it looks like Eric said the resource limit with a question mark, and that's part of it. So the impact of the first ladder, a single ladder enables Chuck to pick up 4 bushels of fruit. When he starts to add more ladders, the second ladder gives him 2 more bushels, and so on, as we've kind of seen. Now, as more ladders are added, this outcome is going to kind of reflect this principle of diminishing marginal product, or you'll hear it said sometimes as diminishing marginal returns. And what that states is that the marginal product of an input is going to fall as the quantity of that input rises. So diminishing marginal product is generally going to apply across all factors of production at both the micro and macroeconomic levels. And what that means is that's where the slope kind of flattens out of this line and we're no longer getting more. This is not special to our example of one man on an island. It occurs in the entire macroeconomy in general. And it's a cornerstone inside of the solo growth model. So what's happening here is no matter how many ladders he has, he's still just one man. So even if he has, 4 ladders that are all set up, he's really not going to be able to move any faster at a certain point. And that's because of the limitations of his human capital. So adding the physical capital in this case doesn't really compensate for the lack of additional human capital. And with like the McDonald's example, just because we keep adding more and more human capital, we don't really have the physical capital of the space or the machinery or things like that to have our workers be productive. And that's why we kind of have that diminishing marginal product, because we're not always going to be able to produce more with just one of these inputs. So this graph right here, or this picture, shows the Eisenhower Interstate Highway System. The image on this slide is kind of a real-life example of diminishing marginal product of capital. So the network of highways shown on this slide connects all the major cities in the U.S. These highways obviously make it a lot easier for us to kind of transport things, to move services across the nation. An example here, a couch that gets manufactured in North Carolina can be transported exclusively by interstate to Cleveland, Ohio in less than 8 hours. Before we had these highways in this interstate system, that same trip between High Point and Cleveland would have entailed driving on several state highways, some that only have 2 lanes, some that have a lot of traffic lights, and it wasn't as quick by any stretch of the imagination. So our highway system is a really big tool that contributes to our GDP. It makes it easier to get places, to move things, to produce. Now, if the highway system somehow were closed down completely, our GDP would immediately fall. On the other hand, if we start to think about this, how useful would it be to find, have an additional network of 50,000 miles of interstate highways? So what would be the marginal product of an additional highway system? Well, we know it would probably be positive, right? More highways seems like it would make things faster, seems like it would make things easier. But just as certainly as we know it would make things easier, this overall impact would really fall short of the positive impact of the first existing network of highways. So why do you think adding a second system of highways would not be as productive as this first system was? Do you think that people just like the old highways? Do you think that there's not enough space for it to really be necessary? What are some reasons that adding a second full system of highways wouldn't be as useful as our first was? It would be useful, it would improve some things, but it wouldn't be as useful or have as much marginal product benefit as the first system did. You'll have to bear with me a little bit today. This is a chapter that obviously works much better with kind of face-to-face and in-class discussion, but we'll just kind of do our best to work through this together, without having that typical interaction that we would. So I don't see any answers coming in yet, but the second system of highways would not be as beneficial as the first was, because the first system was a major change. From no highways to suddenly having this intricate highway system, we became much more productive. While a second system of highways would make us more productive, it wouldn't have quite the dramatic impact that the first set did, because we had already done that major kind of investment before with the first system. Now we're going to look at figure 12.4 from your book. We have our x-axis, which is capital, and our y-axis, which is going to be our real GDP. And this is going to show you kind of the general production function for a macroeconomy. So the slope of this function, you need to notice, is positive. So it's increasing. That means that the more capital that we add, typically our GDP is going to rise. So for example here, if we look at all of these different points, the slope at K3 is not going to be as steep as the slope of K1 or K2. And what that indicates is we have positive marginal product, but the capital is going to have a less positive effect at K3 than it does at K2. So what that means is when we go from 0 to K1, the slope is very steep because we've had a high positive marginal product. From K1 to K2, it's still a positive marginal product, but it's not as big. Same thing from 2 to 3 and 3 to 4 and so on. So if we hold all other factors fixed that are going to influence our output, so land and labor, the important theoretical contributions at this stage are that marginal product of capital is positive, but also declining. So what that means is it's going up, we're becoming more productive, but how quickly and how sufficiently we're becoming more productive is leveling off the further that we go. This is really positive, and it has striking implications for the macroeconomy, and this is kind of the basis for most discussions about growth theory since 1956. So here's our different points to show you that they are increasing our real GDP, but it's increasing by less every time that we move further out to the right. So here's a practice what you know. According to the idea of diminishing marginal product, where will capital have the highest marginal productivity? Very good, Eric. You said D, and that is correct. Capital will have the highest marginal productivity in countries that have a small amount of capital. So think the highway system that we talked about. If you don't have a lot of capital and then all of a sudden you input some new capital, there's going to be the highest impact where there's the least amount of previous capital. And that's because of that diminishing marginal return or diminishing marginal product. So wonderful job. So 2 theoretical implications here. The first one is going to be steady states. So in reality, we know that capital is really expensive and that we'll only replace our capital or add additional capital whenever the benefits from those additional units are going to exceed our cost. With positive cost of capital, this is going to happen somewhere to the left of K4 on that graph that we looked at. perhaps even at K3. So this is going to be before we get to that major arc. You can think of this, the steady state, as the stagnant state. So when the economy reaches its steady state or its stagnant state, real GDP is going to stop increasing and economic growth altogether is going to stop. If you go back to that Castaway example, he reaches his steady state whenever the new ladder is not worth the time it would take to build. So he's going to stop building ladders, and as his income growth stops as well. Now, this image right here, the aggregate production function, which is what this is used to illustrate the way that a major destruction of capital affects the macroeconomy in the short run. So there's going to be a question about this a little later, but let's say that we have some capital that is destroyed. So say that we go from K1 back to K2. You can see that if we do have a machine that breaks or some form of capital that is destroyed, our GDP is going to decrease. That's going to be the short run effect that happens pretty quickly. So just keep that in mind. Now with investment, we have depreciation and we have net investment. So depreciation, this is the fall in value of a resource over time. You know, factories, they become outdated, machines wear down, roads crumble, all of these things happen. So some positive investment is going to be necessary just to keep up with depreciation. Now, if investment is just sufficient to offset depreciation, the overall capital stock won't increase because there's no new net investment. And net investment is investment minus depreciation. So to increase our capital stock, net investment has to be greater than 0. And in a steady state, there's no net investment. So if there's no net investment, that means that we're only replacing capital as is necessary to combat depreciation. If we want to have net investment, we want to have new investment, we need to invest more capital than just what our depreciation is taking away during the cycle. Now, back to those two theoretical implications, we have convergence, and we'll talk about kind of how that applies to marginal product. So theoretically, GDP per capita in developing nations should grow at a faster rate than in developed economies. If one nation reaches that steady state, it doesn't necessarily mean that all nations did. And in other words, countries that have lower levels of GDP per capita should have higher growth rates of GDP per capita. So think Liberia versus the US. Developed economies in the past have already made new discoveries, and because they made these new discoveries and they documented mistakes, developing nations can benefit from these discoveries and avoid kind of those same mistakes that allows them to sort of quickly develop the best equipment, tools, and practices. So if a developing nation is starting to build cars, they don't have to start with a Model T and a basic labor-intensive assembly line. They're able to kind of go straight to those more developed practices. But the question here is, if developing nations in theory should grow at a faster rate than developed economies do, why don't they? Because we've already kind of seen that's not always the case, right? Theoretically, if we're going with this model, they have all the information, the blueprint is already made, they just have to apply it. But that doesn't work. And we'll kind of talk about why that doesn't exactly work a little bit later in this chapter. So just to kind of graphically show you what convergence looks like, this is figure 12.5 from your textbook. And we're looking at kind of a historical example here. So in 1980, the US had a lot more capital than China did. And this is one reason why the real GDP for the US was a lot higher. Now, in the years since 1980, China has really increased its capital stock sustainability, and they've grown a lot more rapidly than the US. With the solo model that we've been talking about, this implies that we here in the US are a lot closer to our steady state, and therefore that's why we grow more slowly than China. If our two nations were completely identical except for capital, China's growth should eventually converge to the US level. So what that would look like is this original point over here. This is China's capital in 1980 and China's real GDP in 1980. And the theory here is that China will then grow and merge with where the US was in 1980. Now, does our model match the data? That's the question here. So the questions that they're asking that we want to ask here, if we were looking at a different example, to figure out if our model matches the data, is a factory in Haiti more productive than a factory in Germany? And are people willing to invest in Haiti instead of the US because of this higher expected rate of return? The data that we have here does not exactly show that. So the theory of convergence is going to imply that the answers to these first two questions are yes. With what we've learned so far and what we've talked about, it would be wise to say that yes, a factory in Haiti would be more productive than a factory in Germany. And yes, more people would want to invest in Haiti than the US because from this model that we've looked at only, we would expect a higher rate of return. Now, the data that we have in reality shows little to no evidence that this is actually true. So some poor countries have experienced rapid growth, like China, South Korea, Singapore, India, and Chile. But these are really the exceptions, not the rule. So during the second half of the 20th century, a lot of developing countries have continued to kind of stagnate instead of experiencing these high growth rates that we would expect. In addition, a lot of wealthy countries are still experiencing really strong growth rates rather than slowing down or hitting that steady state. And some countries have seen slow growth in the recent decades, so the US, but not enough to really close the gap between what are considered rich countries and what are considered poor countries. In fact, we've seen a lot more evidence of divergence, which is widening that gap between wealthy and poor countries, than we have convergence. So something is missing here, right? With our basic solo model, just based on that information, something is not right. So this is really clear today, and it was also clear in the 1950s. The solo model really implies that faster growth is happening in developing nations, but economic growth in wealthy nations often outpaces these poor ones. When we look around the world, it's really clear here that developed nations, their growth has not stopped, but it has also caused economists to kind of reevaluate this model of economic growth because technology really has become more of a key determinant. So just to kind of give you a brief recap here, the solo model focuses solely on capital. It cares and thinks that capital was the most important driving factor in economic growth. But now that we're starting to see that that data is not maybe right, we're starting to realize that technology is really a key player. So capital and growth, there is a strong correlation between wealth and output. Workers are more productive when they have more tools. But as we've stated before, capital alone is not going to be enough to sustain growth. So what we need here is a more advanced version of this model. So we're going to talk about the new, more sophisticated version next. So the original solo model focused what as the main source of economic growth? Very good. I see some answers starting to come in, and C is correct. Capital was the main focus of the solo model as a main source of economic growth. Now, Solo 2, this is the newer version of this model. There were some major implications of changes that happened here, and here's what those were. Increases in technology were one of the biggest things. Obviously, when technology increases, we can produce more output with each input unit. A zero growth long run equilibrium is avoidable, so graphically, as the marginal product of capital increases, the production function is going to shift upward. So remember that when we talk about technology, we're referring to the knowledge that is available for use in production. This model, or this version of the solo model, is more accurate because the changes in technology meant that we could kind of continue that growth, and a zero growth long run equilibrium was avoidable. We didn't have to level off. So graphically, an increase in technology is going to shift that marginal product of capital curve upward, but it won't be a direct parallel shift. And we'll talk about more of what that means here in just a little bit. Now, the Solo 2 equation that we have here, the only difference here is this A at the beginning. So now we're saying that output is technology times a function of physical capital, human capital, and natural resources. So what that means here is that we have our original model, the function of the three things that were in the original solo model, but now we're multiplying these changes in technology by that function, and this is kind of giving us a better idea of output. So new technology is going to mean that output is going to be higher for any given level of capital. So the capital which embeds the new technology is a lot more productive. And a good example to think about this is that a personal computer that we have today is far more productive than personal computers of even 10 years ago. If any of you had a computer that was at your house 10 years ago, you know that those computers and the internet and things like that, it has nothing on what we have today. So the new version of this solo model includes a scalar or a numerical constant that allows for technological advancement. And in this equation, more technology is going to increase the value of A, and then augmenting this model with A explains why economic growth can continue, even though we previously thought that it would eventually hit that zero growth steady state. Now, it is also important to remember that with new technology, any given level of capital, the output is going to be higher. So technology makes everything better. That's kind of the main takeaway here. Just to kind of show you graphically, we have our old version, which is F1, and then we're increasing with new technology. So this is the new solo model formula, but then when we increase that A value, you can see that it shoots that curve upward. It makes us more productive at all levels. So that's something important to kind of keep in mind as you're looking at this stuff. So in the second solo model, how were technology advances modeled? And I don't think that we've explicitly said this today, but we did talk about it some Tuesday. Remember, we thought that technology shocks were random. So I'll kind of give you this one since we didn't really cover it today. We did cover this Tuesday. But, you know, technology shocks in this second solo model, we still thought that these were random and exogenous. And what that means is they just kind of happened. People sort of got lucky with how technology was discovered and things like that. If prices and wages both were changing at the same rate, nothing was really changing in real terms, but they both went up, so there was kind of a non-adjusted increase. So that's kind of like a way of saying that that increase was exogenous. It really just occurred from the outside. And that's how we thought that technology was affecting this model. Now you'll come to find as we move further on that that's not true at all, that technology shocks are not random or exogenous, but that's what they thought then. Now let me go ahead and pop this slide up and we'll talk about it. These kind of things that are listed on this slide are variations on the idea that economic progress really derives exclusively from resources and technology. So when treated like capital, an increase in human capital, this would be something like education, is going to have very similar effects to technological advances. And what this does is it shifts our production function upward. The larger the population, the larger the value of the denominator, and the smaller the value of GDP per capita. So the direction of causality between access to healthcare and GDP growth is difficult to assess here. While healthcare and GDP are correlated, it's less clear whether increases in healthcare are going to cause high levels of GDP or if it's the high levels of GDP that are causing increases in healthcare. So all of these things are important to the solo model, but it's a little bit harder to determine how important some of them are in comparison to others. Now, exogenous technology change. Let me go ahead and pop this slide up for you, and we'll talk about it. The assumption basically was that innovation occurred in wealthy nations, but not because of any inherent characteristics. So similarly, poor nations were poor simply because there were random technology shocks that didn't happen there, they happened elsewhere. Now, we thought that technology increases just happened to hit. Nothing the economy produced in the economy is causing that change until in 1980 when new models incorporated that technological change into the model and started to see it as more of an endogenous or from the inside factor. So economic models are developed mathematically, which for better or for worse, kind of means that we have to simplify these assumptions in order to make them more widely solvable and understandable. A lot of models of economic growth have to include a lot of interrelated factors, and they start to get really complex really quickly. So the two reasons that we started to kind of assume that technology was an endogenous factor rather than an exogenous was because technological practice or progress, it often is lucky and random, but it made our models a lot easier to solve when we thought it was just kind of a random thing. And as we started to incorporate it as more of an endogenous factor, we started to see that it actually was not quite as random as we thought. And although it makes the model a little bit more difficult to solve, it makes it a lot more accurate. Now let me go ahead and pop this up. So some results of SOLO, we know that wealth comes from capital and technology, and that wealthy nations fund a lot of capital investment in poor countries. Two types of aid in the 1950s and 60s. We had actual capital goods that we were out building with aid, and then we also gave aid to developing countries to kind of fund their own infrastructure. Now, some results of these were some countries received billions, and they're no better off today than they were in 1960, like Haiti. And some countries received almost no aid and no help at all, and they've grown rapidly. An example for you, in 1964, the US, Great Britain, and the World Bank, they all funded the building of a big dam in Ghana. It was called the Akosombo Dam. The purpose of the additional infrastructure of building this dam was to create hydroelectric power and a lake that could provide water transportation and development of a fishing industry. So that was kind of the goal behind the US and Great Britain and the World Bank funding the building of this dam. In addition, aid was sent to developing nations in order to increase their capital expenditures, so highways, bridges, ports, things like this. But unfortunately, these efforts were really largely unsuccessful at promoting economic growth. And almost 50 years after that dam was completed in Ghana, the average income level rose by only about $300 per person. So that was an example of aid being given, but it not really producing the impact that we thought it would. Now, some similar situations occurred in Zimbabwe, Liberia, Nicaragua, and Haiti. These countries all have similar levels of GDP per capita today as they did in 1960, despite billions of dollars of aid that they've received. And in contrast, places like Taiwan, Chile, China, and India, these places have received virtually no aid, yet they've grown pretty rapidly. So the SOLO model theoretically seems very airtight, but in the direct application of this model in the real world, we have some woefully inadequate results, right? We're not seeing the results that we would expect to see. So the question here is, why are so many nations, after the guiding and direction of growth economies, still so poor? And that's why we have this modern growth theory. So the SOLO model and the SOLO 2 model that were adapted, these were kind of original ideas. But once we started to see that the aid wasn't fixing what we thought it was, that the advice to developed countries wasn't really developing those undeveloped countries, we have now modern growth theory. So before we get into what modern growth theory is, there's a SOLO case study that your textbook talks about. And basically it's talking about Africa. And it's saying that from 1956 to 1977, 37 African countries achieved independence. This was a unique opportunity to kind of apply that model. So heavy capital investment products were invested in Africa. Just one second. All right, so we started to build these hefty investment projects. We thought that it would give us strong evidence that the SOLO model was accurate and complete, but the results, these policies failed, the growth theory was incomplete, the policy wasn't good, and we had to re-examine the entire theory as a whole. So that is kind of what triggered that change and triggered us to move towards modern growth theory. Okay, we're gonna go ahead and skip this one because we're running a little bit out of time, and modern growth theory is very important, so I wanna get that covered. So modern growth theory focuses on the particular reasons that some nations experience technological advancements while others do not. Rather than just kind of assuming that it's random and things like that, we want to see what exactly is happening with technology. Growth is sustained through technological innovation that occurs indigenously, which is from the inside, which is driven by factors inside the economy. We no longer assume that these are random. We no longer assume that it's exogenous. We went ahead and said, technology is very kind of calculated and it's not just randomly occurring. Now, Robert Lucas is a Nobel Prize winning macroeconomist, and there's a quote from him on this slide that says, "Is there some action a government of India could take that would lead the Indian economy to grow like Indonesia's or Egypt's? If so, what exactly? If not, what is it about the nature of India that makes it so? The consequences for human welfare involved in questions like these are simply staggering. Once one starts to think about them, it's hard to think of anything else." And basically, this is why it matters for policy. If technological change is based on pure randomness, that would mean that there wasn't much that we could do to encourage natural growth. It would mean that some places we're just destined to be poor, and some places we're destined to be wealthy. Now, on the other hand, if technological change is caused by factors inside the economy or endogenous, we can influence growth by trying to change the economy so that it kind of fosters the support that's needed for these technological advances. And we're going to go ahead and skip this video. Here's a practice what you know. So it wants to know, how does the modern growth theory model technology and technological change? Yes, very good, Eric. The correct answer is A. So technology change is endogenous and depends on factors that currently exist in the economy. It's not random. It's not really like what we thought it was before. Modern growth theory realizes that institutions do have an effect on how technological progress and innovation occur, and this makes technology endogenous. So very good. Great answer. Now, going back to institutions, these are the significant practices, relationships, or organizations that frame the incentive structure. So remember, we talked about this quite a bit on Tuesday, but the main takeaways here are that proper institutions can create an incentive for growth. Whenever people think that they have rights and that they're protected, they're more likely to innovate and to work harder. So institutions can be formal or informal. These are going to dictate the production environment and also help determine the costs and benefits of production. Different institutions are going to create different incentives, and this is going to promote or hinder growth depending on how these institutions work. Broadly defined, you can kind of break it down into good institutions and bad institutions. So we talked about these in the previous chapter at pretty great length. If you're still not sure about what these are, definitely go back and look at that last chapter. Now, it's important to know here that the right institutions are going to lead to economic growth. Positive institutions are going to be transparent, consistent, private property rights, stable money and prices, all of these things. Negative institutions are things like corruption, political instability, anything along those lines. So the modern growth theory augments that traditional solo model by adding in institutions down here. And what this says is that the growth of your real GDP is going to be a function of technology times the functions of physical capital, human capital, natural resources, and institutions. So that means that technology multiplied with all of these resources that you have is going to impact your overall success of your economy. So this is just a small change, but the fourth variable really kind of lays that foundation for endogenous growth. And it really helps us emphasize, and a lot of economists have started to realize and recognize the role of strong institutions in growth. These institutions provide the incentive to innovate and come up with new technology and for growth to emerge. Now, table 12.2 in your book just kind of talks about some institutions that do foster economic growth. This is just a good slide to keep with you when you're working on your inquisitives and working on preparing for your next exam. So I would definitely just kind of make a note. This is slide 38, and that's table 12.2 in case you missed that. Now, institutions are going to determine incentives. I'm going to go ahead and pop this up before we talk about it. So how do institutions affect production decisions? Well, investment occurs if we expect that our payoffs are going to be greater than our costs. Payoffs for production are going to have a time lag, and the value of these payoffs is going to depend on the type of output produced, while the costs are usually paid up front. So because of this delay in the resources that are required, firms really have to believe that the sacrifice, patience, and effort that they put in is going to offer a real payoff in the future. So the sprouted seed that they're posting in this image here is just kind of representing that time lag. So often today's investment takes a long time to kind of come to fruition. And sometimes we're not really patient enough for this result, but voluntary investment will only occur if we believe that our expected payoff is going to be greater than our costs. Now, institutions, just kind of a little more on that incentive. Let me pop this up. Consider your decision on whether or not to invest human capital to attend college. So whether or not it's worth it for you to go to school. So human capital is going to be the skills, abilities, and training that you have as an individual, and you're voluntarily spending time and resources, like money, to acquire human capital, which is that education. The reason being is that you expect that your return on investment in education is going to be higher than that cost of attending college. So college will increase your general training. It'll give you some specific on-the-job training when you gain employment. It gives you kind of all these tools. And while you're exerting hard work today, sitting through these classes, studying, taking your tests, doing all this work, you're spending your resources as well. So your time, paying your tuition and fees, the opportunity cost that you have of not being able to work at the same time as being in this class, all of these different things. And you're doing this for the future payoff. So hoping that you're going to get a higher paying job when you graduate, hoping that having a degree will make you more employable, all of these things. Investment in production naturally will occur if future payoffs are significant and predictable. So that is saying that the incentives for the investment are strong enough. On your end, you have enough data just from seeing maybe you have family members that went to college, or you just kind of know in general that typically people that do go to college and do stick it out, that they end up being paid more. So that's why you're being patient, because the incentive is that by investing your time, money, all this stress and effort, that eventually it'll pay off and you'll get paid more. Now, this is figure 12.7. The goal of here is economic growth, but it all starts with institutions. So this is the new model, the modern growth model that includes institutions. And the stronger that these institutions are, the more productive all of these other aspects are going to be. So our natural resources, human capital, and physical capital become more productive, i.e. the higher slope on this function, whenever we have strong institutions. Now, here's a practice what you know. Why are proper institutions important for economic growth? Very good, Eric. The correct answer on this is C. Institutions create that incentive structure in which growth can occur. So the conclusion here, to kind of like tie everything together, theories about economic growth really affect the lives of real people. There is and should be a very strong interaction between theory, policy, and empirical evidence. Theories are converted to policies, and they're evaluated based on those empirical observations. That first solo model really just focused on capital. The adjusted solo model included the role of technology, but really just thought that technology was random. And now the modern model uses all of these things, but sees that technology is indigenous, and that also institutions are going to foster that indigenous growth as well. So that this chapter really just kind of builds pretty seamlessly onto chapter 11. There's not a ton of new math or anything like that. It's just a lot of really good economic concepts. I really appreciate you guys being on today, and I'm sorry that we had a bit of technical difficulties at the beginning. If you would, please go ahead and type your name in the comment box, just so that I can get a kind of roll written down for today. Because we did have a little bit of lower attendance today, and we did have some technical difficulties, I do want to give you guys a little bit of extra credit for your attendance today. So again, if you'll just go ahead and type your name in for me so that I know that you were on today, that'll give me what I need to go ahead and apply that extra credit. It'll probably be a little bit of extra credit onto that participation grade, or on your overall inquisitive grade. So either way, you're going to get a little bit of extra credit from attending our lecture today. If you have any questions, please go ahead and type those. If not, I hope you have a great weekend, and I will speak with you guys again on Tuesday. But thank you again so much. I really appreciate you guys taking the time to log on and taking the time to kind of interact on these lectures. So thank you so much, and have a great weekend. I'm going to stay on until I get everyone's names written down. And I will go ahead and include Teresa on that as well, because I'm not sure if she was able to get back in, but I know she was trying. So Teresa, if you're watching this later, you are being included on that extra credit, because I know that you were on the call earlier today. So you guys have a great weekend, and I'll speak with you on Tuesday. Thank you so much. And it looks like the only person who I do not have down on attendance, the YouTube name on the account is Dubois. If you would let me know what your first and last name are so that I can include you on that attendance. But other than that, I have Eric down, I have Isela, I have Mario. Okay, very good. Thank you so much. So I have all of you guys down. You're good to go, and I will see you Tuesday.